Now we'll discuss about chemical properties of group 14 elements from p block elements. Oxidation state: carbon and silicon have +4 oxidation state. Germanium tin and lead show both +2 and +4 oxidation state. The +2 oxidation state is more stable than +4 oxidation state as we go down the group. What is Fajan rule? Fajan rule: smaller is the cation, the greater is the covalent character in its compounds. How we can define the Fajan rule? Smaller is the cation, the greater is the covalent character in its compounds. For example, tin Sn plus 4 oxidation state compounds are covalent and Sn plus 2 compounds are ionic in nature. Catenation, the property of how we can define the catenation, and also we say what is catenation property. The property of self-linkage leading to the formation of long chains and rings are termed catenation. In simply, self-linkage property and forming the long chain is called catenation. The property of self-linkage leading to the formation of long chains and rings is termed catenation. Carbon has a greater tendency of self-linking than other elements. Carbon has a greater tendency of self-linking than other elements. Catenation tendency follows following the order. First one element is carbon. Carbon having the greater tendency to follow the property of catenation as compared to other elements like silicon, germanium, tin, lead. Bond energies Bond energy value between carbon-carbon is 347, between silicon-silicon 222, between germanium GAGA bond क्या होगा उसकी bond enthalpy क्या होगी 167, and between tin 155. Since the metal bond सेम एलिमेंट्स के अंदर जो बॉन्ड बनता है, बॉन्ड इंथैल्पी डिक्रीजेस स्टिलली from carbon to tin. Therefore, the catenation tendency also decreases on the group. Formation of multiple bonds, pi bonds. Carbon forms stable multiple bonds with itself and other elements. Carbon forms stable multiple bonds with itself and with other elements. First one, carbon-carbon double bond, carbon-carbon triple bond, carbon oxygen double bond, carbon nitrogen double bond, carbon nitrogen triple bond, carbon sulfur. Other elements of this group show no tendency to form pi bonds. However, a few compounds containing multiple bonds have been isolated. Effect of pi bonding on the structure may be seen in graphite. Hydride formation. Covalent hydrides of the type MH4 means that atom or element having 4 hydrogen atoms. forming the four bond with four hydrogen atoms are known as hydrides, are known for all group 14 elements except lead. Tendency of hydride formation decreases in going from carbon to lead. Carbon forms a large number of cyclic and acyclic hydrides known as hydrocarbons. Carbon forms a large number of cyclic and acyclic hydrides known as hydrocarbons. Silicon and germanium form fewer hydrides of the general formula silicon SiN H2n plus 2 and germanium Gen H2n plus 2 known as silanes and germanes respectively. Oxidation state, oxide formation. How the elements form the oxides with other elements. Group 14 elements form three types of oxides. First one is monooxides, MO, monooxide means one element form with other one element of oxygen bond. Dioxide, one element form two bonds with two oxygen atoms. Then dioxides, mixed oxides, more than two oxides called mixed oxides. All elements of group 14 aspect silicon form monoxides of the formula MO. While carbon monoxide is neutral, all other oxides are basic in character. Carbon monoxide is the most important monoxide. All group 14 elements form dioxides having the formula MO2. These oxides differ in their properties and structures. Halides formation. Elements of group 14 form the following types of halides: MX4 type, carbon tetrachloride, example is carbon tetrachloride. MHX3 type, example is chloroform, CHCl3. MX2 type, example is silicon chloride, silicon dichloride. Dihalides of germanium, tin and lead are more ionic in nature. Dihalides of germanium, tin, lead are more ionic in nature. The stability of dihalides increases in going down the group. Tetrahalides of the type MX4 are known for all elements of group 14. Tetrahalides are tetrahedral and covalent. The tetrahalides of all elements except of carbon undergo hydrolysis. टेट्राहैलाइड जो हैं of all elements के except of carbon undergo hydrolysis means they give the reaction with water. Carbon having the symbol C, Latin word है carbo meaning charcoal. Atomic number is 6, atomic mass is 12.01. Most common element graphite diamonds and coal. Most common compounds hydrocarbons and carbon dioxide. Most common element of carbon is graphite diamonds and coal. Most common compounds is hydrocarbons and carbon dioxide. Physical properties of carbon is a soft, dull gray or black nonmetal that can be scratched with a fingernail. The density of carbon as graphite is 2.267 gram per milliliter, which means it will sink in water. Carbon uses used in diamond jewelry, diamond used in jewelry manufacturing tools in making dyes. And then graphite, lubricant at high temperature manufacturing lead pencils. Third one is coal, coal used in fuel manufacturing coal tar, coke, and coal gas manufacturing synthetic petrol. Coal manufacturing synthetic petrol. Silicon, about silicon is that symbol of silicon is Si. Latin word of silicon is silicium. Atomic number of silicon is 14. Atomic mass of silicon is 28.09. Most common compounds of silicon is silicon dioxide, mostly silicon dioxide, also called silica sand, silicon dioxide SiO2, silicon carbide SiC, silicon silicate, sodium silicate Na2SiO3, and silicon tetrachloride SiCl4. Physical properties of silicon is that crystalline silicon has a metallic grayish color. Silicon is relatively inert, but it is attacked by dilute alkali and by halogens. Most important point of silicon is relatively inert, but it is attacked by dilute alkali and by halogens. Silicon transmits over 95% of all infrared wavelengths. Wavelength range is 1.3 to 6.7 millimeter. Silicon uses. What's the application of silicon? Electronic devices such as transistors, diodes, and chips. Silicon are used in electronic devices. Electronic devices is transistors, diodes, and chips. And then silicon used for producing ferrosilicon. And third one is as a dioxidizer in steel industry. And then fourth one is important to plant and animal life. Germanium. Introduction about germanium is that symbol is Ge, capital G and small a. Latin word germania. Atomic number of germanium is 32 and atomic mass of germanium is 72.60. Most common compounds of germanium is oxide GeO, GeO2, germanium dioxide, colloids GeCl2, GeCl4, and hydrides GeH4, Ge2H6. Most common compounds are oxide, colloid, and hydride. Physical properties. What is physical properties of germanium? Germanium is a lustrous, hard, gray-white, semi-metallic element. What's the physical properties of germanium is lustrous, hard, gray-white, semi-metallic element. Germanium expands as it freezes. It is a semiconductor. Germanium and the oxide are transparent to infrared radiation. Germanium and the oxide are transparent to infrared radiation. Germanium uses, what's the application of germanium element? First of all, semiconductor devices. Germanium used in semiconductor devices. Second one is that making prism lenses and windows in instruments based on IR. Used as catalyst. Germanium also uses catalyst. Is the most important point of germanium is used as catalyst. Introduction of tin. Symbol is SN, capital S and small n. Latin word is tannum. Atomic number of tin is 50 and atomic mass is 118.69. Most common compounds is SnF4 फ्लोराइड्स के साथ, SnCl4 क्लोराइड्स के साथ, SnBr4 ब्रोमाइड के साथ एंड SnCl2 डाइक्लोराइड्स के साथ. Physical properties of tin is a malleable silvery white metal which takes a high polish. Second one is that it possesses a highly crystalline structure and is moderate ductile. Tin, it possesses a highly crystalline structure and is moderately ductile. When a bar of tin is bent, the crystals break. The most important point is that when a bar of tin is bent, the crystals break, producing a characteristic tin cry. Tin has a cubic structure. Upon warming at 13.2 degrees centigrade, grey tin changes into white. On warming tin at 13.0 for 13.2 degrees centigrade, grey tin changes to white. Tin uses. What's the application of tin element for tinning of copper and brass utensils? Most important point is tin is used for copper, tinning of copper and brass utensils, for making tin fuels for wrapping cigarettes, for making tin foils for wrapping cigarettes. Third one is that making alloy, solder, bronze and gunmetal. Fourth one is that tin oxide, dioxide coated glass is scratch resistant aircraft windows. Fifth one is that tin is used in agriculture to control fungi such as potato blight. Lead. Last one element of group 14 is lead. Introduction of lead is that symbol B, capital B and smaller b. Latin word of lead is plumbum. Atomic number of lead is 82 and atomic mass of lead is 207.19. Most common compounds of lead is PbCl2, lead chlorides, lead oxides, PbO2, PbNO2, twice Pb3O4, PbCH3, fourth. Physical properties of lead is that lead is a soft, malleable, and poor metal. It is also counted as one of the heavy metals. Most important point is that it is also counted as one of the heavy metals. Metallic lead has a blush white color after being freshly cut, but it soon tarnishes to a dull grayish color when exposed to air. Lead has a shiny chrome silver luster when it is melted into a liquid. Lead has a shiny chrome silver luster when it is melted into a liquid. Lead uses. What's the application of lead? First of all, lead used for making water pipes. General application of lead is that used for making water pipes. Second is most popular example of lead is that used in storage battery. Lead used in storage batteries. Third one is that for making bullets, shoots, etc. Then alloys, solder forming in solder alloys. Mixing of two metals are called alloys. And fourth one use of lead is used for preparing high refractive index glasses. Fourth one and last one application of lead is that used for preparing high refractive index glasses. This is all about the group 14 elements in the periodic table of p block elements.